Favorite module in pure mathematics because it has vectors and trigonometry. So this tells us the lines y equal 3x plus 4 and 4y equal 3x plus 5 are inclined at angles alpha and beta. And it says state the values of alpha, tan alpha and tan beta. So let's do this. This is module 2 now. So it tells us say you have a line y equal to y is equal to 3x plus 4, I think. And then them tell us that the next line is 4y equal to 3x plus 5. So you see the second line right here is not in its standard form. So if you put the next line in standard form, this is y equal to 3 over 4x plus 5. That is it. So if you were to sketch this right here, you see this graph right here, 3x plus 4, 3x plus 4. This have a gradient of 3 and a y value of y-axis intercept of 4. So this would be it right here, 4. All right. So the tan of alpha, this is alpha, right? This is alpha right here. So what we know is that the tan of alpha is the gradient. So that means that the tan of alpha is going to be equal to 3. That's the first thing. If you don't believe me, look at it, right? This right here, this point right here would have been, what is that? When y is 0, this would have been, y is 0, this would have been negative 4 over 3. Negative 4 over 3, right? If you don't believe me, this is alpha. Use trigonometry then. This length would be 4. This length would be 4 over 3. Use trigonometry and get alpha then. But I'm telling you the tan of alpha would be 3. That's from that graph right here. Now, if you want this one now, this one pass through 5 over 4. And this have a gradient of 3 over 4. So it's not that steep. So it looks something like this. And it passed through this point right here is 5 over 4. So that means that this one have an angle of the gradient right here. So this is beta. And so what that means is that the tan of beta is 3 over 4. Tan of beta is 3 over 4. Always remember that the tan of an angle is equal to the gradient of the line. The tan of an angle is equal to the gradient of a line. Tan of an angle is equal to the gradient of the line. We must know this. So that's it. Let's write that down around here. So what is tan alpha? Tan alpha is 3. What is tan beta? That's 3 over 4. Now it says, without using tables or calculators, find the tangent of the angle between the two lines. So to find the tangent of the angles between the two lines, so this is part 1, module 2. To find the tangent of the angle between the two lines, see it here now, part 2. Right? So we're finding the tangent of the angle between the two lines. I'm just going to sketch what is going on. I know we like to see the sketch. So see that black line right there? You have that line first. And then you see this, well, I didn't put it in black. So let me put the next one in black. Then the next line right here will go something like this. Five over 4. I want to make it look something like this. So let me fix the first line a little bit. All right, let's say this is the first line and that's the second line, all right? So look at this. This right here is alpha. This right here is beta. All right, all of this, what we are saying is all of this angle is alpha. This is alpha, and this right here, so this little piece is beta. All right, now the whole thing together now. So what I'm asking for is the tan of, in bracket, alpha minus beta. That's what they're asking you for. All right, so they're asking us for tan of alpha minus beta. Now we're just going to use this formula. Tan alpha minus beta is the tan of alpha minus the tan of beta over 1 plus tan alpha tan beta. Easy, don't it? Yeah, man, we'll say, oh, pure math so easy, man. 1 plus tan alpha times the tan of beta. Yeah, man, we're nice. We're nice, we're nice, we're nice. So what this works out to be, is tan alpha is 3 minus the tan of beta is 3 over 4 over 1 plus tan alpha times tan beta. 1 plus 3 times 3 over 4. Now, I'm not in the best of shape right now, meaning to do addition. So I'm going to go for the calculator. I know it is embarrassing, but it is what it is. So it's just going to be 3 minus, in bracket, 3 over 4 divided by 1 plus 3 times, in bracket, 3 over 4. As I said, not in the best of addition shape. Maybe a couple of years ago, but not right now. So this is 9 over 13. Final answer is 9 over 13. That's it. Nice. That's the tan of alpha minus beta. All right. Nice. Yeah, man. Because remember, what I'm showing you, the whole thing is alpha. This part here is beta. So the tan of alpha minus beta, if I were to use another color, is just that piece here, right? Because if the whole thing come around at alpha, but a little part here beta, this is alpha minus beta. That's all just fine. All right. Moving right along. It says prove that the sine of 2 theta minus tan theta times cos theta is tan theta. All right, so we need to prove this. Oh, by the way, let me write down the answer we'll get right here. So we'll get 9 over 13. And now we're going to do this proof. So now we need to prove. All right, I don't like the color green. This doesn't look that pretty. Let me go back here. Prove that the sine of 2 theta minus, what was that again? Tan theta cos 2 theta, tan theta cos 2 theta, and we need to show that this is going to end up being equal to tan theta. There are many ways to do a proof, but we know the traditional way is to start with our left hand side, and maybe you can do it one way and I do it another way. It doesn't matter. So let's see how we can do this. Now, first thing is sine 2 theta. Start with your left hand side, sine 2 theta minus tan theta times the cos of 2 theta. This is what we're starting with, minus tan theta times the cos of 2 theta. Now this right here, sine 2 theta, this right here, sine 2 theta is really 2 sine theta times the cosine of theta. Yeah, man, that's 2 sine theta times the cosine of theta. Minus, I'm just going to keep tan theta, okay? And then cos 2 theta, I know that this can be written as, maybe I can say 1 minus 2 sine square theta. 1 minus 2 sine square theta. Now, why did I do that? I did that so that I can factor out something in common. So let's see what this will simplify to be. What we'll end up getting is 2 sine theta cos theta. Then this is now minus Just if I wanted to change the tan, let's change the tan, right? If I were to change the tan, I'm going to change tan for now as sine theta over cos theta. All right, I'm going to change this to sine theta over cos theta just for now. So if I expand this in, I would get this times this is now minus sine theta over cos theta. And then right here, so now I would have minus and minus become plus. That will become 2 sine squared times sine is then 2 sine cube theta over cos theta. That's what I end up get, 2 sine cube theta over cos theta. Yeah, man, that's what I end up get. So now what I can do is make everything have a denominator of cos theta. So look what I'm going to do right here. Follow quickly. I'm going to put a square right here, and then I'm going to divide it by cos theta. So pretty much what I did was multiply this term by cos theta over cos theta. By doing that, I will end up get one fraction in the numerator. I end up get 2 sine theta cos squared theta minus sine theta plus 2 sine cube theta. And this is all being divided by cos theta. I shouldn't have taken this route, right? I shouldn't have taken this route, not one bit, because this route end up being much longer. All right, this route end up being much longer. I should have actually taken the 2 cos squared theta minus 1 route. All right, so let's fix that, all right, because I want to finish it really quickly. Instead of using this formula, we're going to use 2 cos squared theta. 2 cos squared theta minus 1. We're going to use this formula. Because why? Then this times this would become, this one times this one would become minus 2 sine theta. Yeah, we're going to take that route because it's going to finish off really quickly. So my apologies about this. I was going to take that route, but then I would have to do too much that for 3 marks. Yeah, man, that's too much for 3 marks. So we're going to take this route, 2 cos squared theta minus 1. That's the route we're going to take. So taking this route, what we're going to end up getting now is 2 sine theta cos theta. Then this becomes minus sine theta times cos squared, so that becomes minus 2 sine theta cos squared theta over cos theta. Now remember, if you have a square right there, so right, then that means one of the square I got cancel out the cos theta in that denominator. Then minus and minus give plus, so you end up get plus sine theta over cos theta. Yeah, you see how fast this I got done now? Because guess what? Since the square cancel out this, you end up have 2 sine theta cos theta minus a 2 sine theta cos theta, and that part becomes 0, right? Because this part right here, just to show it a little better, you have 2 sine theta cos theta minus 2 sine theta cos theta, and then we have plus tan theta. That part that we know is 0. Then we have a plus tan theta. Yeah, man, we have a tan theta. This part right here is 0. So it end up equal to just tan theta, which is our right hand side. So that's how you do this right here. You don't have nothing to worry about. That's easy. We could have used the 2 sine square, but just to take a little longer. And we don't want to take too long for a 3 marks question. So that's that. All right. So that's that. Easy. Soft. Now it says express tan theta as the subject. So it's telling us from this formula, make tan theta the subject. So first thing is we have that sine 2 theta minus tan theta cos 2 theta is equal to tan theta. This equal tan theta. So first thing you need to do is group the tan theta then on one side. Group the tan theta then on one side, bring it over here. So now we're gonna have the tan of theta. We'll bring it over to one side. So we have tan theta plus tan theta cos 2 theta is equal to sine square theta. I know I wrote it on the wrong side. You're probably saying, why over there? Yeah, it don't matter. It does not matter. All right, I bring over it over here to have tan theta cos 2 theta plus tan theta equals sine square. Then what I'm going to do now is factor out my tan theta. So when I factor out my tan theta, I'm going to be left back with tan theta from tan theta is 1 plus, this is now cos 2 theta, and this is equal to sine 2 theta. That's not a square, it's a 2. I know I write it pretty awful there. It's a 2. All right, so that's sine 2 theta. So then now I can divide both sides by 1 plus cos 2 theta to end up get that tan theta. The expression for tan theta is equal to sine 2 theta over 1 plus cos 2 theta. Easy, soft. 1 plus cos 2 theta. Yeah, man, easy, soft. That's the 2 marks right there. Now the next part it says is to hence show that the tan of 22.5 degrees equal root 2 minus 1. So it wants us let theta equal 22.5. So let theta equal 22.5 degrees. If we put theta as 22.5, that will become the tan of 22.5 is equal to, now if you put theta as 22.5, 22.5 times 2 is 45. So that end up work out to be equal to the sine of 45 over 1 plus the cos of 45. Yeah, man, sine of 45 over 1 plus the cos of 45. So what we end up get is, this is now the tan of 22.5 is equal to 1 over, well, not 1, the sine of 45 over 1 plus the cos of 45. And we're going to simplify this expression. Now the sine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. And this is then divided by cos of 45 is 1 plus root 2 over 2. So we need to simplify this now. So to simplify this now, I'm first thing, write the denominator as one fraction, that's root 2 over 2 divided by 1 can be changed to 2 over 2. I can change 1 to 2 over 2. So this denominator is really 2 plus root 2 over 2. And so now remember, when you have a fraction like this, A over B, go back to CSEC math or maybe prep school. You can write it as root 2 over 2. And you can flip it. So it's now being multiplied by 2 over 2 plus root 2. When you're dividing, you flip it. So this 2 cancel this 2. So end up get, this is now root 2 over 2 plus root 2. And then, of course, we have to multiply by the conjugate. The conjugate of what? The denominator, which is 2 minus root 2. If we multiply by 2 minus root 2 and multiply by 2 minus root 2. And this is going to work out to be, this works out now to be root 2 times 2 is 2 root 2 Then we have root 2 times minus root 2. That's just minus 2. Then in the denominator is the difference of 2 squared, which is 4 minus 2. So this works out to be, factor out the 2 from the numerator, we get 2 times root 2 minus 1. And that is being divided by 4 minus 2 is 2. This 2 cancels this 2. So we end up get root 2 minus 1. Sharp, sharp, sharp. See that we're done. So we're nice. So we end up get with root 2 minus 1. Nice. Moving right along. Now this part says now, given A, B, and C are angles in a triangle, prove that the sine of A plus B over 2 is the cos of C over 2. That's the first one. So you have one triangle, right? You have a triangle. It doesn't have to be right angle triangle. You have a triangle and then tell you that A, B, and C are angles of a triangle. You have A, you have B, and you have C. Yeah, A, B, and C. And then tell us that these are angles of a triangle. So since A, B, and C are angles of a triangle, what do we know? What we do know, if A, B, and C are angles of a triangle, is that, see it here, A plus B plus C is equal to 180 degrees. All right, that's what we do now. That's a starting point. Now, by the way, I just want to write back down what we're trying to prove. We're trying to prove that the sine of A plus B over 2 is the cos of C over 2. So this is what we need to prove. Sine of A plus B over 2 is a cos of C over 2. This is what we need to prove. All right, so that's what we're required to prove, right? So now we'll start with this, that A plus B plus C is 180 degrees. Now look at this. If I were to subtract C from both sides, I could end up see that A plus B would be equal to 180 degrees minus C. Yeah? And then what I can do next is divide both sides by 2. I can divide both sides by 2 to get that A plus B over 2 is equal to 180 minus C over 2. So that means that A plus B divided by 2 is actually equal to 180 over 2 is 90 minus C over 2. Now look at this now. I can take the sine of both sides. So therefore the sine of A plus B over 2 would end up equal to the sine of 90 minus C over 2. Yeah, man, maths easy, you know, maths are easy, especially pure math. 90 minus C over 2. So this is what we have. So this is then equal to, if you're to expand this part, the sine of 90 minus C over 2, if you expand that part, that is equal to the sine of 90 times the cos of C over 2. And then it would be minus, this would then be the cos of 90 times the sine of C over 2. But then guess what? The sine of 90 is 1, so this works out to be 1 times the cos of C over 2. And then the cos of 90 is 0, so that's minus 0. So see, the sine A plus B over 2 is what you're left back with. So the sine of A plus B over 2 is equal to the cos of C over 2 minus 0, which is just the cos of C over 2. So see, they're proven. We're done. See, they're proven. Nice. You write soft with a capital T. Soft. Yeah, man, it that easy. Nice. So let's continue. It then says now show that sine B plus sine C is this weird formula right here. So, all right, so then write down what we're required to prove next. So the next part now is required to prove sine B plus sine C. I was supposed to show, so this I got equal to, let me see, that is 2 cos A over 2, 2 cos A over 2 times the cos of B minus C over 2. This is what we need to show. So first, let's start with our left-hand side. Our left-hand side, we start with, it is equal to sine B plus sine C. Now to do this, remember how you find sum of two sines. Sum of two sines is twice the sine of half the sum times the cos of half the difference. The sum of two sines is twice the sine of half the sum, which is B plus C over 2, times the cos of half the difference, times the cos of half the difference, which would be B minus C over 2. But guess what? Didn't we just prove that sine A plus B over 2 was the cos of C over 2? Yeah, man, we just proved this. Look on this, we just proved this. We just proved that the sine of A plus B over 2, we just proved this. And so what am I trying to tell you? I'm trying to tell you that if you remove or if you replace this right here, if you replace A plus B with B plus C, what you realize, what you get? Replacing it, you realize that the sine of B plus C over 2, when you have A plus B, you end up with a cos C over 2. So B plus C will give you a cos A over 2. Yeah, man, it's just that easy. That's what we end up get from this right here. So that means that around here now, we can end up say, see that part here, sine B plus C over 2, that would work out to be 2 times the cos of A over 2. And then we write back our cos B minus C over 2. The cosine of B minus C over 2. Yeah, man. B minus C over 2. Our nice. That's equal to our right-hand side. That's our right-hand side. Soft, soft, soft. Yeah, man, we're done. Now the next part now. The next part now says we're required to hence show that sine A plus sine B plus sine D is 4 cos A over 2, cos B over 2, cos C over 2. All right, that one they look spicy. Yeah, man, that one they look spicy, man. Show that the sine of A plus the sine of B plus the sine of C. I'll need for sure set this equal to 4 times the cos of A over 2 times the cos of B over 2 times the cos of C over 2. That looks crazy, but it's not. It's really easy. The cos of C over 2. All right, nice. So let us do this right here. To do this right here, we're going to start with our left-hand side. Our left-hand side, it's equal to sine A plus sine B plus sine C. That's sine A plus sine B plus sine C. Now bear this in mind. Remember that sine, well, I'm not going to trouble sine A right now. I might say, sir, why not? Because we had already found sine B plus sine C, right? We already said that sine B plus sine C is this. We already said sine B plus sine C is that. So I'm going to substitute that for sine B plus sine C. That sine B plus sine C is 2 cos A over 2 cos B minus C over 2. So this is 2 cos A over 2 cos B minus C over 2. All right, I'm going to substitute this for sine B plus C over 2. That's why it says hence, the question says hence. Now look at this now. You see this sine A right here? I'm going to rewrite sine A as the sine of 2 times A over 2. So I can apply double angle formula. Oh, yeah, man. I'm going to write it as sine 2 times A over 2 plus 2 cos A over 2 times the cos of B minus C over 2. Times the cos of B minus C over 2. Nice. So now right here, so you see this sine 2A. This sine 2A is now 2 sine A over 2. This is 2 sine A over 2. Cos A over 2 when I expand it using the double angle formula for trig. Yeah, man. So this becomes 2 sine A over 2 cos A over 2 plus right back all of that over there, which is 2 cos A over 2 times the cos of B minus C over 2. Yeah, man, this is what we have. Okay, now first thing I realize is I'm going to use a different color and I'm going to factor out. I notice both of them have cos A over 2 in common. So I'm going to factor out 2 times the cos of A over 2. I'm going to factor out 2 times the cos of A over 2. And what I'm left back with is factoring out 2 times the cos of A over 2. I'm left back with the sine of A over 2 plus from this over here, I'm left back with, this is now the cos. When I factor out cos of sine A over 2 plus, I think this is cos B minus C over 2. Okay, cos B minus C over 2. All right, yeah, man. So this is what I have now. All right, now I was almost about to panic, but then we don't need to panic. This is sine A over 2. There must be something for sine A over 2. Let's check back. We know what sine A plus B over 2 is. That is the cos of C over 2. All right, let's see how we could find an expression for the sine of A over 2. Because that would give us, we need something with cos in it, right? We really can't add we can't add a sine and a cos. All right, so let's just remain calm. Now we have sine A over 2. Let's see what happens now. So going around here now, remember we already know that 180 is equal to A plus B plus C. 180 is A plus B plus C for the triangle there. So if we subtract B plus C from both sides, we get 180 minus in bracket B plus C. That would be equal to A. This would be A. And so if we were to divide both sides by 2, we would end up get that A over 2. So the angle A over 2 would be equal to, this is going to be 90. 180 over 2 is 90 minus in bracket B plus C over 2. Yeah, man, that's what we end up get. So then now if we take the sine of both sides, that means the sine of 90 minus B plus C over 2, 90 minus B plus C over 2. If we take the sine of this would also equal to the sine of A over 2. Yeah, but then the sine of A over 2, that's going to be the sine of 90 this is going to be sine 90 times, this is now the cos of B plus C over 2, cos of B plus C over 2. Then it says minus, this is then going to be the cos of 90 then times the sine of b plus c over 2. And that's equal to the sine of a over 2. That's the sine of a over 2. But guess what? We know that the cos of 90 is 0. So this part right here is 0. And then the sine 90 is 1. So sine a over 2 is just the cos of b plus c over 2. So this end up work out to be, because the cos of 90 is 0, we end up get the cos of b plus c over 2 is equal to the sine of a over 2. This was what I was looking for. So find our missing piece. All right, this was what I was looking for. B plus c over 2, the cos of that is the sine of a over 2. So we're going to plug that in right here now to end up get that. This is equal to, this is now, let me try and finish it off right here. So I'm going to try and finish it off right here. So let me remove the equal right here and put an equal right here. So to say it's continuing, that's equal to 2 times the cos of a over 2. And then inside the bracket now, the sine of a over 2 becomes the cos of b plus c over 2. And then that is now being added to plus the cos of b minus c over 2. The cos of b minus c over 2. All right, so adding these two now, what we're going to end up get is this is actually working out to be 2 times the cos of a over 2. And in bracket here, this works out to be, we have 2 cos adding. How do we add 2 cos? The sum of 2 cos is twice the cos of half the sum times the cos of half the difference. That's how we add 2 cos. Adding 2 cos is twice the cos of half the sum. So we need to add up b plus c over 2 plus b minus c over 2. So that is b plus c over 2 plus b minus c over 2. And that's how we need half the sum, twice the cos of half the sum. Close that. They will multiply it by the cos of half the difference. The cos of half the difference is b. I need a little more space. I can't squinch it up here. This is going to be b plus c over 2 minus b minus c over 2 over 2. Minus b minus c over 2 over 2. So all we did is use the difference, the sum of 2 cos formula. Yeah, man. So what is this going to work out to be? We're almost done, by the way, so don't stress yourself. It's 5 marks that we're going to get. So it's 2 times the cos of a over 2. In brackets here now we have b plus b is 2b. 2b over 2 is 1. 1b, and then 1b over 2, that's now just the cos of, this works out now to just be the cos, oh, I left off the 2 right here. The 2 right here, so this is now 2 times the cos of, b plus b is 2b, 2b over 2 is b. This works out to just be 2 times the cos of b over 2. Then over here, the c's them cancel, by the way. Then this end up work out to be the cos of, in bracket, this is going to be minus c over 2. When I simplify it, that's easy. And then this 2 times this 2 is 4. So that equals to 4 times the cos of a over 2. 4 times the cos of a over 2 times the cos of b over 2. And then guess what? The cos of minus c over 2 is the cos of c over 2. Always remember that identity. So that's the cos of t over 2, which is our right hand side. We're nice, which is the right hand side. Soft, capital T, soft, soft. So see it there? This is the proof. All right. So just again, the last identity that we use that you must know, let me put it right here, is that the cos of minus theta is equal to the cos of theta. Always know this. Cos of minus theta is the cos of theta. Yeah, man. They must know. So we can tell them to this soft, 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 soft. Yeah, man, soft. All right, now on to question 4. All right, question 4 time. Why is it doing? It's jumping. It's jumping a little bit. Let's scroll back up. It's question 5. Why is it jumping? Let me fix that. Oh, because it's still under text. Let me close it. No, it should be fine. Yeah. This is question 4 now. Okay, we're ready again. Question 4. Just have to make sure it's the right one. Yeah. Question 4. Yeah. So question 4 now. Come on, now stop with this poor Zoom. All right, so this is question 4. Question 4 says, in the Cartesian plane with origin O, all right, this says in the Cartesian plane. So we're at question 4 now of section. All right, so now we're at question 4, still in module 2, and it says in the Cartesian plane with origin O, it tells you the coordinates of P and Q, they give it, and they say the midpoint of PQ is M. So even before I finish off this question, it says the midpoint of PQ is M. I'm just gonna find M from now. All right, I'm just gonna find M from now. So it gives us a P of coordinates -2, 0. That's the coordinates of P. It tells us a Q of coordinates 8, 8. And M is the midpoint of this. So midpoint of PQ, can write it as MPQ. Midpoint of PQ is going to be equal to, it's -2 plus 8 divided by 2, comma, 0 plus 8 divided by 2. So we're just writing down PQ from now. We don't know what they're going to ask yet, but just to write down what the coordinates of M is. So M, which is the midpoint of PQ, is -2 plus 8 is 6 over 2 is 3, and 8 over 2 is 4. So M of coordinates 3, 4, just to bear that in mind. M of coordinate 3, 4. All right, so just bearing that in mind, we can, where M of coordinate 3, 4. It says find the equation of the line which passes through M and is perpendicular to the line PQ. So we want to find the equation of the line that is perpendicular to the line PQ. So if it's perpendicular to PQ, first thing we need to do is find the gradient of PQ. So find the gradient of PQ. The gradient of PQ is y2 minus y1, which is 8 minus 0 over x2 minus x1, which is 8 minus minus 2. 8 minus minus 2, that work out to be 8 minus 0 is 8. 8 minus minus 2 is 10. And so the gradient of PQ is 4 over 5. Since the gradient of PQ is 4 over 5, then the line that is perpendicular to PQ, so we can tell them gradient of the line perpendicular to PQ is the negative reciprocal. So let's call this line, I don't know, gradient of the line perpendicular to PQ is equal to negative 5 over 2. Did I say 2 or 4? Negative 5 over 4. That's the gradient of the line perpendicular to PQ. So now to find the equation of the line perpendicular to PQ passing through M, it's going to be given by, it's y minus the y value at the point, y minus the y value at the point 4, and that's equal to the gradient of the line, which is minus 5 over 4, times x minus the x value at the point, which is x minus 3. So we expand that in and we get y minus 4 is equal to, I'm going to multiply through by 4 first. So we get 4y times y minus 4 is equal to negative 5x plus 15. That's the first thing we can do. And then we expand in the 4 to get 4y minus 16 is equal to negative 5x plus 15. And so what we can do now is bring over the 16 over there to get 4y is equal to, that would be, bring over the 16, that's 31. That's negative 5x plus 31. That's the equation of the line perpendicular to PQ passing through M. That's 4y equal to minus 5x plus 31. All right. So if you want to write it just a little bit better, you can tell them, find the equation of the line. You could tell them it's y is equal to negative 5 over 4 x plus 31 over 4. If you want to make y the subject. Then it says, hence or otherwise, find the coordinates of the center of the circle through P, O, and Q. Find the coordinates of the center of the circle through P, O, and Q. So you have a circle now. I'm going to do that part around here. You have a circle. Let me just draw the axis first. All right. I like to put on my axis then. It just make it easier for me. All right. So around here, you have P is minus 2, 0. So minus 2, 0 is somewhere right here. Let's say this is P. This is P. And Q is 8, 8. So this is minus, this is P. All right. So this 1, 2, 3, 4. Somewhere right here is maybe Q. So let me extend this line. Let me extend this line. Maybe somewhere right here is Q. Somewhere right here is Q. All right. And this is, wait, my apologies. How Q for bit here? So I'm so crazy. I'm crazy, right? Yeah, I'm crazy. 8, 8 is, if this is 8 on the X, we need 8 on the Y, somewhere up here. So Q would be somewhere up here. So yeah, Q would be somewhere up here. So all right, I will need the circle we pass through. Q being 8, 8, P being minus 2, 0, and the origin O being 0, 0. Wow, that which circle pass through all 3 of them points here? So I guess the graph won't really look that pretty there. I can't do it so pretty. So what I'm gonna do is just draw a random circle. Draw one random circle and then put on, say, maybe here so is 8, 8, which is, here says 8, 8, here so is minus 2, 0. Or maybe here is 0, 0, and here is minus 2, 0. All right, so this is the origin O, this is P, this is Q. All right, I just want to show you what's happening. So that's what happened right there. All right, nice. So this is what we have. This is a circle. This is Q, 8, 8, that is P, minus 2, 0, and that is Q, that is O, the origin. And we want to find the circle passing through all of these. And they said hence. Because they say hence, you can't go and go do it in another method. You have to use hence, meaning using an answer in the previous line. All right. I'm sure they said hence. See it here? They said hence. Oh, and they gave you the otherwise option. Okay, you have the otherwise option. You don't have to do it this way. Now, the hence option would mean that, see it here? This is the line PQ. Let me put it in a different color. This is the line PQ. I already know the bisector of PQ passing through the midpoint M. So if you have the midpoint M somewhere right here, if you have M somewhere right here, we know M is 3, 4. I already have the bisector passing through the midpoint, right? We already have the bisector like this, all right? So now the next thing that we need to do is find the equation of the line, let's say OQ. We need to find the equation of the line. Well, not necessarily the equation of the line OQ, but we need to find the bisector of OQ. Let's use a different color for OQ. Let's use blue. This is OQ here, right? So we need to find the midpoint of OQ. We need to find the midpoint of OQ. And after we find the midpoint of OQ, which is going to be somewhere about here, right? What we do know is that the bisector of OQ, the bisector of OQ will pass through the center of the circle. All right, and then the two lines will intersect at their center. All right, the two lines will intersect at the center of the circle C. So we need to find the bisector of OQ. So this is the bisector of PQ. We already have this line that I put in burgundy. This line that I put in burgundy, that line is y is equal to, I think it was minus 5 over 4x plus 31 over 4. We already have that line. All right, we already have that line. And so now we need to find this bisector now, the line OQ. Now the midpoint of OQ, if you want to write it down, that's going to be equal to, divide 8 by 2, that's 4, 4. That would be the midpoint of OQ, 4, 4. So now we need to find the gradient of the line OQ. The gradient of the line OQ would be equal to y2 minus y1, which is y2 is 8, minus y1 of 0 over x2, which is 8, minus x1 of 0, which is 1. So the gradient of OQ is 1. So the gradient of this line is 1. Now we need to find the gradient of this line L. So the gradient of that line L, so the gradient of L is -1 because L is perpendicular. These two lines are perpendicular. So this line have a gradient of -1 and it passes through this point, and that point we know is 4, 4. So the equation of this line then is going to be y minus the y value at that point 4, and that's equal to the gradient of the line minus 1 times in bracket x minus 4. So to finish it off, we expand that out to get y minus 4 is equal to, that look like minus x plus 4. And so this work out to be y is equal to, this is negative x plus 8. This is what we end up get. Y is equal to minus x plus 8. Good. So this is this line right here. Y is equal to negative x plus 8. All right, nice. So after we have this line now, what do we know? We know that this line and this line, they intersect at the center of the circle. So solving them simultaneously will give us the center of the circle. So again, we have the two equations of the two lines. We have 4y is equal to minus 5x plus 31. And then we have another line where I tell we say y is equal to What is y here? Y is minus x plus 8. So we're going to substitute minus x plus 8 into the first line. So what we're going to end up getting now is 4 times in bracket minus x plus 8, and that is equal to minus 5x plus 31. We can expand and simplify to say minus 4x plus 32 is equal to minus 5x plus 31. We can bring over the 5x over here to get 5x minus 4x is x. Then we can bring over the 32 over here to get 31 minus 32. 31 minus 32 is negative 1. So x equal negative 1. When you get x equal negative 1, you can find y now by saying y is going to be minus of minus 1 plus 8. That works out to be 9. All right, and so they intersect at the point of intersection is minus 1, 9. Just to verify it in here, 4 times 9 is 36. Yeah, that's right. So they intersect at minus 1, 9. And so right here, so now, this point C is actually minus 1, 9. That's it. That's minus 1, 9. So that's one way of doing it. So we can tell them that's the center of the circle. So we can tell them that now. So the center of the circle, passing through P, Q, and O is minus 1, 9. Cool. We're nice. That's the center of the circle. That's the answer. Nice. All right. So we can write it down right here. Center of the circle, minus 1, 9. Now it says prove that the line y equal x plus 1 is a tangent to the circle x squared plus y squared plus 10x minus 12y plus 11 equals 0. Now them just diverge, so look how them don't even ask if I find the equation of this circle. That's crazy. Them gonna want another circle. So them give one circle x squared plus y squared plus 10x minus 12y plus 11. Shows that this line is a tangent to the circle. If it is a tangent to the circle, it will only intersect the circle at one point. Let's go ahead and do that. So around here now, then give one circle x squared plus y squared plus x squared plus y squared plus 10x minus 12y and then tell we say this equal, well, plus 11 equals 0. That's the circle. And they want us to show that this line is a tangent to it, y equal to x plus 1. So what we're going to do is substitute the line y equal x plus 1 into the circle. So we substitute the line y equal to x plus 1 into the circle. All right, so we substitute the line y equal x plus 1 into the circle. By doing that, what we're going to get is x squared plus y, which is x plus 1, replace that with y up there to have x plus 1 all square plus 10x minus 12y, which is minus 12 times x plus 1. That would be plus 11, and that is equal to 0. That's what we have. Nice. So now right here, now what we end up get is x squared plus, this is now x squared plus 2x plus 1. And then this is now plus 10x And then we have minus 12 times x, that's minus 12x. Then minus 12 times 1, that's minus 12, plus 11, and this is equal to 0. Nice, 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 nice. So now we just need to simplify. I see an x squared and an x squared here. So that is 2x squared. And then I have a 2x here, a 10x here, and a minus 12x here. 2x and that is 12x. 12x minus 12x, that gone. So that part gone, x them gone. 1, so I end up get 1 minus 12 plus 11, them they gone too. So I end up get 2x squared equals 0, and so I end up get x equals 0. Look how this easy, man. So if x equals 0, repeated. All right, repeated, because when you solve a quadratic, you get two answers. You get x equals 0 and x equals 0. So from this now, x equals 0 repeated and y equal 1 repeated. And so since we only get 1 point of intersection between this line and this circle, see there, 0, 1 is the only point of intersection. And so we can tell them, hence the line is a tangent to the circle. Hence, the line is a tangent to the circle. Yeah, man. So if you're like me and you want to give them a little sketch, I love give them sketch, you know. You can just put on one little circle somewhere, right? So this circle have center minus 5, 6. So it have center minus 5, 6 like this. And then the tangent, then you have the line y equal x plus 1. And the point 0, 1 would be somewhere right here. So this is 0, 1. And so right here, so now if you draw the line, it looks something like this. The line intersect the circle on the right there. So yeah. All right. So that's it. Indeed, the line is a tangent to the circle. Yep. Nice. Moving right along. The next part says find the coordinates of the point of contact of this tangent to the circle. We already did. We did it in two. We did it in one step. The coordinates of the point of contact of the tangent with this circle is 0, 1. So now what you're asking me is, you might say, sir, why would they know that we might solve and show it's one point of contact, then ask us about this? No, what they probably were expecting, you to do is show that when the discriminant of that quadratic is 0, then the line would be a tangent to the circle. Let me write that in words. If you sub the line in the circle, it leads to a quadratic. All right, the word quad for quadratic. If you sub the line in the circle, it leads to a quadratic. Let's continue it down here. If the discriminant for the discriminant spelled wrong. If the discriminant for the quadratic is 0, then the line is a tangent to the circle. That's all. So probably that's what they were expecting us to do in part 1. Then part 2, they want us to solve it. But we don't do 2 of them in 1, so we're not a problem. We're nice. All right, we're really nice. All right, so let's move on now to the next part of the question. Question 5. Where's question 5? Here it is, section 3. Section 3 says, answer both questions. We have limits and continuity. It says, find the limit as x approach 3 of x cubed minus 27 over x cubed plus x minus 12. Let us do that.